Welcome to GER Hub Mathematics and Statistics lessons. Today I shall be discussing the determinant of a matrix. The determinant of a matrix. And the focus shall be on the determinant of a 2 by 2 matrix. So for information or anything you need to know about matrices, just quickly go to our videos on matrices and watch them, okay? So what shall be the focus of this video? It will be the determinant of a 2 by 2 matrix. But before we begin, please subscribe to our YouTube channel as it helps the channel to grow and it helps us to produce more content for you. It also gives you notification on whenever we drop a video on different topics in mathematics, statistics, as well as research. Okay, let us now begin. That being said, what is the determinant of a matrix? So this video begins with giving the determinant of a matrix a definition. So what is the determinant of a matrix? Now I shall define the determinant of a matrix to be the determinant of a matrix is a numerical value. It is a numerical value obtained from a specified pattern of computation performed on the matrix. So what we call the determinant of a matrix is simply a numerical value that is obtained from a specified pattern of computation performed on that matrix. So if you carry out a specified pattern of computation performed on the matrix, then that may just give you what we refer to as the determinant. Now, before we begin further discussion on the determinant, it is very important we take two remarks that are fundamental. Remark number one is that determinants are specifically obtained for square matrices. So that is my remark number one. I want you to take note. So if we are talking about determinants, it means there is a square matrix somewhere. Okay? So determinants are only obtained for square matrices. Okay? So that being said, let's go to remark number two. For remark number two, I want to know that if A is a square matrix, so let A be a square matrix. Okay? Then the determinant of A, if A is a square matrix, then the determinant of A can be denoted by det in bracket A, or by writing A in between two straight lines. So it is either you use this notation, this det with A in bracket, or A in between two straight lines to represent the determinant of a matrix. So wherever you find either of these, it represents the determinant of a matrix if it is found in matrices as a topic or any question on matrices. Now the next thing we want to talk about is the method of computing determinants of a matrix, a 2 by 2 matrix. So for 2 by 2 matrix, there is what we call the normal method. The normal method is used for computing determinants of 2 by 2 matrices. Computing the determinants. What we call the normal method is used for computing the determinants of 2 by 2 matrices. Okay? So we use what we call the normal method for deriving or obtaining the determinants of 2 by 2 matrices. Now, what is the normal method all about for a 2 by 2 matrix? So for a 2 by 2 matrix, the normal method, I'm going to write here, normal method for computing determinants, for computing determinants of 2 by 2 matrices. Okay, so now what does the normal method say? The normal method requires the following. The normal method requires the following. Let A be a 2 by 2 matrix. Then DETA, or the determinant of A, can be obtained as follows. So if you want to obtain the determinant of a 2 by 2 matrix using the normal method, all you have to do is this. Write this and then write the matrix itself: A11, A12, A21, A22. Now, if you remember what we had discussed earlier on matrices, the general form of a matrix, if A is a 2 by 2 matrix, remember that we said that this will be the elements of that matrix. Meaning that this will be the first element in the first row. That is row 1, column 1. So that is why you have 1, 1. This will be the element occupying row 1, column 2. That is why you have 1, 2. Row 1, column 2. This will be the element occupying row 2, column 1. And this will be the element occupying row 2, column 2. So this is what you would have in notation for the determinant of the matrix A if it were to be a 2 by 2 matrix. Now, how do you use the normal method to obtain the determinant of this matrix? All you have to do is take the product of the principal diagonal elements, and that will be A11 times A22. Close your bracket and subtract from your result the product of the auxiliary diagonal element. Remember, this is the principal diagonal. This is the principal diagonal. And this, on the other hand, is the auxiliary diagonal. Auxiliary diagonal. So the elements there are the auxiliary diagonal elements, and the elements here are the principal diagonal elements. So the normal method for obtaining the determinant of a 2 by 2 matrix requires that you multiply the elements along the principal diagonal and subtract from your result the product of the elements along the auxiliary diagonal. So this is A12 times A21, and that will give you the determinant of a 2 by 2 matrix. So we can write this as product of principal diagonal elements, product of principal diagonal elements, close bracket, minus product of auxiliary diagonal elements. So once you subtract the product of auxiliary diagonal elements from the product of the principal diagonal element, it gives you the determinant using the normal method. Now let us take quickly an example. Let us take an example to illustrate what we have done. So all we are going to do here is to take two examples to show you how. So if you have the matrix A carrying 2, 5, 1, 8, and you have another matrix B carrying 7, 3, 9, 4. What we want to do is to obtain the determinant of the matrices A and B. So what would be the determinant of this matrix? It will be written as this or this for determinant of A, and that will give us the product of the principal diagonal elements, that is 2 times 8, and I'm going to write here 2 times 8, minus the product of the auxiliary diagonal element, that is 5 times 1, and that will give us 2 times 8 is 16, so I'm going to write here 16, 5 times 1 is 5, and that gives you 16 minus 5, that will give you 11, okay? Now, the next one I want to show you is the determinant of B, which can be written as DET in bracket b. That will give you, all you have to do to get the determinant of b using the normal method is just to multiply the principal diagonal elements 7 times 3 and subtract from your result the product of the auxiliary diagonal element, that is 4 times 9, and that gives you 21. 7 times 3 minus 36, 4 times 9. Now take note, 21 minus 36 will give you a negative result. It will give you a negative result, okay? That tells you that the determinant of a matrix can also be negative, even as it can be positive. So 21 minus 36 will give you minus 15, okay? So minus 15 is what you have as 21 minus 36, and it is a negative result. So the next one I want to give you is this matrix. I'm going to put here 4, 1 and 4, 1, okay? If you take the determinant of this matrix, you are going to have C equals determinant of C, which is the same as 4 times 1, the principal diagonal element in product, minus 4 times 1. Okay, and that will give you 4 minus 4. 4 times 1 is 4. 4 times 1 is 4, giving you 0. Now, this brings me to remark number 3. Remark number 3. What can you notice from these examples? Notice that determinants of a matrix can be positive, negative, or 0. So, obtaining the determinant of a matrix, a 2 by 2 matrix using the normal method, requires that you only subtract from the product of the principal diagonal element that of the product of auxiliary diagonal elements, and that gives you the determinant of a 2 by 2 matrix using the normal method. Take note, determinants could be positive, negative, or 0. Determinants are represented with the matrix in between two lines, two straight lines, or writing DETC, okay? That being said, thank you very much for watching this video. Please like the video, share the video, and most importantly, subscribe to the YouTube channel GER Hub for more videos on mathematics topics, statistics topics, as well as research writing topics. Thank you very much.